Okay, we'll start now. Okay. So good morning, everyone. Good morning once again. Right. So I hope all of you remember the concept that we have studied in this class. Tell me, sorry, in this chapter, right? I hope all of you know what is work, what is the relationship between work and energy, what is energy, right? Then interconversion of energy, which is work energy theorem, then rate of doing work, right? Okay. So when you talk about this topic, okay, Chandan, I'll check if I've uploaded or not. Okay, right? If not, then I'll upload because many videos are there in unlisted list. Okay, it's not in public. That's why, right? I'll just check. I'll just send the link. Okay, in the group only. Now, in this, we have discussed 4.1. Yes or no? We have discussed 4.1 both in class and homework, right? 4.1 was discussed both in class and homework. Anyone have any doubt? Tell me, those who haven't solved it that time but solved it later. Anyone having any doubt in 4.1? No? No? Okay, very good. 4.2, relationship between work and energy. This also we have discussed, right? This also we have discussed each and every question, right? Guys, I hope all of you are solving everything, okay? Because we will be checking it. We will be checking it, okay? Okay. Now, any doubt in homework section? Any doubt in homework section? Because we have discussed this. 4.1, 4.2, 4.3 we have discussed. We didn't discuss advanced question. That's why we will be discussing advanced question also today. Okay. Now, I hope all of you remember we have discussed till question number 5. I'll upload the recording also. Okay. So we haven't discussed the advanced question. Which one? Which one? Question number? Tell me, Prahlad, which question? Apologies everyone, my internet got disconnected. Wait, just give me a minute. Okay. So question number 1. Can anyone answer me? Question number 1. Tell me, question number 1. Anyone? Tell me, question number 1. Why the work done is negative? Now think about it, right? Think about it. Okay. I hope all of you can hear me, right? Right, everyone? All of you can hear me? Yes. So I can say, we know that force, okay, when we talk about work done, so when force is in direction of displacement, then the work done is positive. But when force is in opposite direction to the displacement, it is negative, right? While catching, the fielder apply the force in opposite direction, right? Yes, yes, very good. Because yes, that's why there will be retardation in the ball and it will stop, right? That's why the work done is negative. Clear? Tell me, clear everyone? You can write down in your own language also. Now, question number 2. Everyone, question number 2. Okay, question number 2. The person is holding a bucket by applying a vertical force of 10 Newton. So vertical force of 10 Newton, 10 Newton, right? Now he moves horizontal to distance of 5 meter, horizontal distance 5 meter, right? And then climbs vertical distance of 10 meter. We have seen this question in an exemplar. I hope all of you remember, right? Prahlad, 4.3 we didn't, right? 4.3 we are coming now. After this we'll solve 4.3, right? Please wait. Okay, we have done this problem in exemplar. So we know that when he moves horizontal, right? When we move horizontally, the force and displacement are 90 degrees. So there will not be any work done, right? So on moving 5 meter, there won't be any work done. Work done will be zero in this case, right? But when he climbs up, right? When he climbs up, okay. So horizontal force is 10, sorry, vertical force is 10 and vertical displacement is 10. So work done will be 100 joule. Easy, clear everyone? Very good, Yashila, very good. Everyone is clear with this concept? Tell me, everyone is clear? Manoj, Prajwal, Afsa, Ahad, Akshata, everyone? Easy? Okay?
Sir.
Okay, very good everyone. Very good, Tapish. Now third one. How is it possible that flock of bird in flight can have momentum zero but not have kinetic energy zero? This is also we have discussed, I guess, right? I hope all of you remember. This is what we have discussed. Yes or no? How many of you remember? We have discussed. Yes, right? Yes. Okay, very good. Next, 4.3. So 4.3 in class exercise 6. 4.3 in class exercise 6, we will discuss again, right? So let's see. Okay, so you are designing a bungee jump from the tower of height 100 meter. So it is a tower, right? The height of tower is 100 meter given, 100 meter given. Okay, the natural length of bungee rope is 25 meters. So the length is 20, sorry, 75. Okay, this length. So this length is, the remaining length is 25. 25. Okay, think about it. This is a good problem. Everyone, please think. Okay, right? This is a good problem. Now, what should be the minimum force of the rope, right? Okay, mass is 100 kg. Right? Mass is 100 kg. Okay, guys, everyone can see it. Yes, screen is not frozen for me. Okay, so think about it. Think about it, right? Okay, very good. Now think about it. I can say, right, when it falls from this height to this height, it will have some kinetic energy. Yes or no? Tell me. Right? Okay, now let's see the question. The natural length is this. Okay, physics, you have to understand first thing that you have to do, right? Write the data, write the data. And it starts applying destroying force when it is stretched beyond natural length. Means after this, it is applying a force in backward direction. Restoring force means backward direction, na? Right? You'll try to pull up, yes or no? Tell me, yes or no? Just imagine if you're dropped from bungee rope, right? So you will fall from 0 to 75 meter, right? But after this, because this rope will stretch, you will go further down, but again, the rope will try to pull you back. Yes or no? Tell me. Same as spring. Yes or no? Right? And that force is your restoring force. That force is your restoring force, which will try to restore your position. Okay. Now, what should be the minimum force of the rope, right? Okay, mass is 100 kg. Mass is 100 kg. Now, this question is very question. Yeah. Now, think about it. What can we do here? What can we do? What concept do we have here? Tell me. He should not hit the ground means the maximum we will fall for 25. Tell me, for 25 meter, yes or no? We have discussed two methods for this. I hope all of you remember, right? Yes or no? Maximum it will fall till, right, 25. So we can use, yes, we can use conservation of energy also, right? So I can say, let us suppose, okay, let us suppose you can find potential energy at this point. Yes or no? Tell me, yes or no? Kinetic energy at this point? Forget about it. This is very easy, right? Okay, you can find potential energy at this point. Suppose this point is reference. This point is reference. Okay, so from this point to this point, what can you say about energies? Tell me. At this point A, tell me. At this point A, we will have both kinetic energy and potential energy. Yes or no? Tell me. I'm not solving this question. I'm just asking a simple concept. At point A, we will have both potential energy and kinetic energy. Yes or no? Yes or no? Yes. Agree with this? Agree with this? Okay. Now at point B, it should have only, tell me, it should have only, no, it should stop now, right? Then only it will back, otherwise it will hit the ground. Think about it, Prahlad. At this point B, this should stop, right? Think about it. If you keep on moving at point B, you will hit the ground, no? Yes or no? You will hit the ground. Just think, right? Imagine what will happen if you are doing bungee jumping. If this point B, if you have velocity, so you will hit the ground, no? Right? Yes or no? Tell me, yes or no? Right? So now I hope all of you remember that when you talk about potential energy or kinetic energy, everything depends on reference frame, yes or no? Yes or no? Because it is change in height. Agree? Okay. So I'll just consider this point as reference frame. I'll consider A as reference frame. Right? Suppose someone is looking from point A. Okay, think about it. Point A. Everyone clear? Now, at point A, if you are actually sitting at point A, then you can say that at point A there's only kinetic energy. Yes or no? Because if you are at point A, then there's no change in height. Yes or no? If you are sitting at point A, then there's no change in height. Try to understand this. Try to understand this. Everyone is getting this concept or not? I'll give you another example, right? Reference frame. This is very important concept. Okay, very important concept. Suppose, suppose, suppose one person is standing over here, one person is standing over here, right? Suppose one person is standing over here, one person is standing over here. Now, if a box is kept over here, if box is kept over here, right? For this person, this object is the same level, yes or no? Yes or no? Right? So what is the potential energy? What is the potential energy of this box with respect to this person? Tell me, what will be the potential energy of this box with respect to this person A? Zero, na? Zero means zero. Yes or no? Yes or no? Right? Yes. Now, suppose this person is saying, this person B is saying, and this height is h, right? So according to this person, what would be the potential energy? First of all, it will be less or it will be more? First, it will be less, it will be more. Less, because less na Yashila, because it is down, right? We know that, right? Higher point have higher potential energy, lower point have low potential energy. Yes or no? So it will be less, right? It is lower, na? It is lower than this. Less potential energy. Got it? Now, how much less? So if the mass of this block is m, right? Then the potential energy of this point, according to person B, is minus mgh, right? Because it is negative. Yes or no? Tell me, yes or no? Clear? right? So I hope all of you understood this concept that potential energy, right? When you talk about height, right? It depends on reference frame. Yes or no? It depends on reference frame, right? From where you're calculating height, because height is again height is relative now, right? You're calculating is it actually from one point to another point, right? So this concept is clear. This concept is clear. Raise your hand. Everyone should raise your hand. If this concept is clear, please raise your hand. That potential energy, when you talk about height, it is depends on the reference frame from where we. Yes, yes. Different frame means point of observation only, right? Okay, from where you are actually calculating the height. Okay, okay. Now, I hope all of you know this. I hope all of you know this, that work done is equal to change in kinetic energy. Very basic formula. Yes or no? Work done is equal to change in kinetic energy. Yes or no? Work done by non-conservative is equal to change in kinetic energy. Okay, right? Yes. That's why I told you, right? Please pay attention to the class. Can we calculate potential energy, guys? Tell me, can we calculate absolute potential energy? Tell me, can we calculate absolute potential energy? No, it is always relative, yes or no? Tell me. It is always relative, it is always with respect to some point, yes or no? Now, think about it. If someone is sitting over here, right, and he's observing two boxes. One box is at this point, right? Think about it. This point, right? This height is h1, right? Now, this box A is taken from this point to this point, which is 10 meters away, 10 meters away, right? Now, according to this person, what is the potential energy of this box? Mass is suppose M, mass is suppose M. What is the potential energy of this box at point A? Tell me. What is the potential energy? It will be M into G into H, yes or no? Yes or no? Right? At point A. But if it is taken to point B, what would be the potential energy? It will be M into G into H plus 10. Yes or no? Yes or no? Right? Now my question is, what is the difference in potential energy? Tell me, what is the difference in potential energy? Difference will be, right, this is potential energy 2 and this is potential energy 1. It will be potential energy 2 minus potential energy 1, which will actually be M into G into 10. Yes or no? Which is actually change in potential energy. Change in potential energy. Yes or no? Tell me. Right? So doesn't matter. Doesn't matter. Okay. Right? Okay. Doesn't matter. Wherever the point of observation is, the potential difference between 2 points will be same. Yes or no? Difference. Got it, everyone? Yashash, got it? Everyone is clear with this concept, right? If you take from this point also, the point of observation is this now, which is suppose the height is 2h. Then again, the potential energy between A and B will always be mg into 10, right? Got it? Tell me, got it? Yes. Okay, so potential energy, we generally see in our syllabus, we write potential energy, but it is actually the difference, change. Okay, got it, with respect to some point, right? When you're talking about respect to Earth. So obviously in that case also you're taking the reference point as the center of the Earth. Yes or no? Tell me. When you're writing MGH, right? You are taking the reference frame as the radius of the Earth, not the center of the Earth. Yes, this concept will be applicable. Okay. Prahlad, see, everyone, you just have to know that the reference frame, point of observation matters. Okay, right? I hope all of you have studied this in motion also, na? Right? Yes or no? Tell me, yes or no? Right? My voice is cracking, Janvi, everyone, my voice is cracking. Audible? Okay. Right now, reference frame, the concept of reference frame is clear to everyone, right? That if you see yourself, okay, from Earth, right? On Earth, you are having two friends which are at rest, right? If someone is sitting on the moon and seeing you guys, so this guy will see you guys in motion, yes or no? So obviously everything depends on reference frame, okay, right? In physics, especially in mechanics, this is mechanics, everything depends on reference frame, okay? Got it, right? Okay, I hope this is clear, everyone. I hope this is clear. Now, let's see this. So I can say, now in this, at 75 centimeter, at sorry, 75 meter, can you calculate velocity? Tell me, can you calculate velocity at this point? Tell me, can you calculate the velocity at this point? Yes. How? Using equation of motion. Using equation of motion, yes or no? B square is equal to U square plus 2gh, because it is falling now. U is 0, right? U is 0. So V is equal to root 2gh, right? Height is 75, right? G is 10, right? So I hope all of you can calculate. Yes or no? Root, tell me, 2 into 10 into 75, right? Got it? Okay. Or just calculate V square, because you have to calculate V square, not just calculate V square. V square is what? Tell me. 1500, right? V square is 1500 at point 75 meter. Yes or no? Tell me. Yes or no? V is equal to 7 V square. Puneet, right? Think about it now. At 100, it is zero only now. Think about it. At 100, it will be zero. Velocity will be zero now. See, till this point, it will be free fall. Yes or no? Till the rope, right? Till the length of the rope, it will be free fall. Free fall means you're falling under the gravity, right? That's it. But after 475, the rope will try to pull you back, right? There'll be opposing force, right? So you will reach till point this, which is 100 meter, but you will stop at this point. Yes or no? That is the problem. Yes. So there's no external force exactly, Prahlad, no external force in free fall. That's why the acceleration is g only. We can calculate velocity over here. Velocity over here we can calculate, and velocity at this point is zero. Yes or no? Tell me yes or no. Everyone got this concept? Tell me step by step. Everyone got this concept? Yes, very good. Okay, very good. So I can say, right, kinetic energy at 75, kinetic energy at point A, which is a point A is at 75. Point A is equal to at 75 meter. Okay, 75 meter. And point B is 100 meter. Okay. So kinetic energy at point A is equal to half mv square, and kinetic energy at point B is equal to 0. So changing kinetic energy is equal to what? Half mv square. Changing kinetic energy is equal to, tell me, half mv square. Yes or no? Tell me yes or no. Agree? Agree with this, everyone? Agree with this? Step by step, right? And we know that work done, which is force into displacement, is equal to change in kinetic energy, right? Yes or no? According to work energy theorem. We have two methods. There's one more method, right? I'll teach you this. There's a reason why I'm doing this. I'll teach you second method also, right? Which is much easier one. So think about it, right? Think about it. Now this F is equal to what? Half mv square by S. Clear? Now we know m, we know v square, we know s also. S is what? 25 meter, now, right? Tell me yes or no. Tell me yes or no. Can you calculate this, guys? Can you calculate this? So yes, it is, right. 7500 75,000 by 25. So it is 3000 Newton, right? Got it? Clear, everyone? Clear? Everyone got it? Please, if you didn't get, please ask. I've taught you a whole concept, not just this problem, a whole concept, right? Concept of reference frame, concept of change in potential energy, change in kinetic energy. So this we calculated using kinetic energy. Can we do it with potential energy? Tell me. Can we do it with respect to potential energy? Yes or no? Tell me. Yes or no? Think about it. Tell me. Homework 1, 2, 3. Tell me. No? Clear? Everything is clear? Right? So question number 3. Anyone have any doubt in question number 3? Please raise your hand. I'll explain. Question number 3 was a good problem. Question number 3 is a good problem, right? So yes, some people have doubt. Okay. So we'll discuss question number 3. Now think about it. A lift of mass 100 kg. First step, write down the information, right? So mass is given as 100 kg, right? Mass is given as 100 kg. Okay, given. Carrying men and women of total mass 300 kg suddenly falls. Now imagine physics, imagine, right? Okay, imagine what happens. Okay, right? Think about it. So total weight is, see, lift mass 1000, yes. And mass of men and women is 300. So total mass will be how much? Total mass will be how much? 1300 kg. Now, it suddenly falls. So if suddenly falls means it is free fall, yes or no? Right? Okay. Now it is saying that the velocity of lift before falling was 24 meter per second. So V initial was 24 meter per second. So I can find initial kinetic energy, yes or no? Yes or no? And the lift was at the height of 40 meter. So I can height initial potential energy also, yes or no? Tell me, yes or no? This is based on work energy theorem, yes or no? So initial kinetic energy, initial potential energy is given, yes? Raise your hand, guys, yes?
Sir, now 24 meter per second, is it going with that velocity? Is that going upwards or downwards, sir?
See, it is falling now, so it is, we will take it as going downward only, right? Okay, because it doesn't matter if it is
Sir,
going
it
up.
was,
Wait,
sir,
it doesn't,
it's going, it was,
yeah, tell me.
sir, it was going at 24 meter per second before falling. So basically, the fall cannot decide whether it was going up or down.
Doesn't matter, because when you talk about kinetic energy, potential energy, are they vector quantity or scalar quantity? Think about it. Tell me, right?
So
Because
scalar.
right, when you're writing half mv square, you're writing the magnitude, right? Doesn't matter if it is upward or downward, right? It is the value. Okay, so it doesn't matter, and you cannot say that it is going upward or downward. Okay, right? So you don't have to worry, because even if it is going upward or downward, right, the kinetic energy at this case will be same. Okay, right? So let's rewrite the kinetic energy initial. Kinetic energy initial will be how much? Half into m total, which is 1300, into v square, which is 24 square. Potential energy initial is equal to how much? M, which is 1300, into G, which is 10, into height H, which is taken as 40. 40. Now, it is said that what would be the velocity when a height of 35 meters above the ground? So, potential energy final, right? Potential energy final at 35 will be how much? 1300 into 10 into 35. Yes or no? Tell me, yes or no? And what is work energy theorem? Work energy theorem says initial energy, kinetic energy initial plus potential energy initial gives potential energy final, sorry, is equal to potential energy final plus kinetic energy final. Yes or no? Tell me yes or no. This is your work energy theorem, right? Now, since if you talk about this, right, mm will be cancelled, right? Mm will be cancelled. Okay, right? So just rewrite the equation. So it will be what? Half into mm will be cancelled because mass is there, right? And it is same, so it will be cancelled. So it will be half into 24 square plus 10 into 40 is equal to half into v square plus 10 into 35. Can you calculate? Can you calculate v? Tell me. Can you calculate v now? Shrishti, can you calculate v now? Calculate. Try calculating velocity. Everyone, try calculating velocity. Think about it, right? If it falls down, the velocity should increase, na? Tell me, yes or no? Yes. So if you calculate, right? If you calculate, the answer would be 26. Okay. So let's calculate, everyone. Let's calculate. So multiply 2 with everyone. So it will be 24 square is equal to v square or 24 square. I'll wait. I'll just take everything to that side. Okay. Take this to this side and multiply with 2. So v square is equal to 24 square plus 2 into 10 into 40 minus 2 into 10 into 35. Yes or no? Tell me yes or no. So it will be, tell me, it will be what? V square is equal to 24 square plus, now this is equal to 2 into 10, 20 into 5, 100. Right? Yes or no? Yes or no? 800 minus 700. So it will be 100. So 24 square plus 100 will be what? Tell me. I hope all of you can say. Very good. Right? 676. Because, got it? So root 676 is 26. Clear? Clear? So V is equal to 26 meter per second. Got it? Right, everyone? Yashash, what was your doubt?
Sir, I had
Everyone
a
got this concept?
sir, I had a doubt कि
Yes?
आपने so you have used kinetic energy and potential energy and then you have found the answer. So but here we know that mass is like acceleration does not depend on mass. So sir, can we just use the third equation of motion by taking the distance displacement as 5 meters?
Yes, it is same only, na? Right? Think about it, right? I wanted you to use this, to learn this, right? Otherwise, if you think about it, right? Think about it. Don't you think that this is the same concept, right? If you write the formula, right? Write the formula half m v1 square plus m v1 is equal to half m v2 square plus mgh2, right? Take this to this side, this to this side. So it will be what? v2 square is equal to v1 square, will get cancelled, right? Plus g h1 minus h2, right? Into 2. So there's nothing new what you're saying, Yashash. It is the known fact. It is basically the same thing, right? Same thing. Where do you think that this equation is derived? Tell me, right? This is from here only, na? Got it? Yes or no? Right? And we actually understood this only. So both are actually the same thing. Okay. Right? Okay. It's not two different method at all. It is same method, same concept. Okay. Right? It's just that this formula is basically based on this only. Next. So advanced question, let's see. Okay, now energy can exist in several forms and may change from one form to another. For each of the following state, the energy change that occurs in the unwinding of watch spring, the unwinding of spring watch. Tell me which energy is changing? Which energy is changing into which energy? Think about it. When you stretch the spring, right? Which, yes, very good of potential to kinetic energy. That's what happens, right? Potential to kinetic energy. Good. So potential energy to kinetic energy. Yes. Okay. Now, a car going uphill. Tell me. Now here, right? Okay. Yes, you just write potential energy, okay? Right, you just write potential energy. Is elastic potential energy in your syllabus? No, na, right? This is what we have studied here, right? So in your exam, right, what is in your syllabus? Otherwise, it might be like, I don't know, right? You might, no, where it is opposite. Here, it is fuel energy. You burn fuel, right? So it is, see, it is chemical energy. First of all, chemical energy to, tell me, kinetic energy. Yes or no? Tell me, chemical energy to kinetic energy.
Clear, sir.
Third one is
So, but
chemical
it,
energy. Yes?
so but it is gaining height, na sir?
Yes, then this kinetic energy is converting into potential energy. Okay, right? But what is the reason? What is that? Basically, both will be the correct answer depending on what you're considering, right? Okay, got it, right? If I would check paper, I would give both answers correct. Okay, this is change in overall energy form and this is change in, tell me, mechanical energy. Okay, so both would be correct for me, but totally depends on your teacher. So you can write both, right? You have to write both. Okay, clear? Right? Yes or no? First, fuel is converting, fuel is used, so chemical energy is used in kinetic energy. Okay, now, yes, you can write, but write in the proper way, Yashash. Fifth, okay, so I'm leaving two. Two, a loaded truck when starts and set in motion. Easy, this is what? Loaded truck, right?
Sir, potential to kinetic.
Again, right? When it is
Sir,
same, na?
chemical to kinetic.
Same, chemical to kinetic. Chemical to kinetic. And this was chemical to kinetic to potential, right? Got it? Right? You have to write this complete thing. Now, fourth, photosynthesis in green leaves. Photosynthesis in green leaves. Akshata, electrical to mechanical, you can't say because you have to be specific. Oh, you are saying fifth one. Yeah, fifth one is correct. Charging of battery. Charging of battery is
Electrical to mechanical. Electrical to chemical.
yes, electrical to chemical, right? Because when you're talking about battery, it is chemical, right? Yes. Fourth, we have done, right? Fourth is sunlight to chemical. Fourth is sunlight to chemical. Okay, right? So basically light energy to chemical energy, to chemical. Okay. Fifth, electrical energy to chemical energy. Okay. Respiration, tell me, respiration. I hope all of you know what is respiration. It is chemical to heat. Yes or no? Tell me, yes or no? right? Solar light ही होता है ना, okay? Burning of matchstick, burning of matchstick.
Chemical to fire.
Fire is both heat and light, right? So chemical to both heat and light, okay, right? Explosion of crackers.
Chemical to sound and light.
Yes, chemical to heat, light, and sound, all the three. Chemical to heat, light, and sound. Okay? Yes. Okay? Respiration is not a muscular formula, Yashash, right? Okay? Now, after this, question number two. Question number two. Let's think about question number two. It is a very good problem. Everyone, question number two is a good problem. So, a machine which is 75% efficient. So, what is the efficiency? Tell me, what is efficiency? What is efficiency?
So capability to do work.
Okay, so basically, what if you want to save the formula? Don't you think it will be output by input? Output by input, right? Yes, right? For example, right? If I'm teaching 1.5 hours, right? If I'm teaching 1.5 hours, but some person, right? Suppose some of you are joining 20 minutes late, are joining 20 minutes late and sleeping for 15 minutes, right? Right? Then how much they would have studied? Less, right? Or okay, slept for 20 minutes. Slept for 20 minutes. So they would have studied only for 40 minutes, right? 50 minutes, yeah, 50 minutes, right? So what would be the efficiency? Tell me, what would be the efficiency? It would be 50 divided by 90. Yes or no? Right? So tell me, what is your efficiency, everyone? 100% is not possible. No one is paying 100% attention except for some, right? I know whose efficiency is 100%. See, efficiency is how much output is. See, for example, right? Okay, efficiency. When you talk about efficiency, okay, it is how much output, right? Yes, Krishna. Okay, very good. You're 100%. Yes. So those who are replying regularly, Ashila, Mansa, Yashash, right? But some people don't ask, they just wait for teacher to say, right? So their efficiency would be less because they're not utilizing. So efficiency is the utility. You can also say utility, right? Okay, so efficiency is basically the output by input. Okay, means suppose you are using your bike, right? Suppose you are using bike and you use 5 liter of petrol, 5 liter of petrol. Okay. Now, normally 1 liter, in 1 liter you can drive 50 kilometers. Suppose in 1 liter you can drive 50 kilometers, right? Then in 5 liter, how many kilometers you could drive? Tell me. How many liters you could drive? Sorry, how many kilometers you can drive in 5 liter? How many kilometers? Very good, 250,
250.
right? But you are actually traveling 200 kilometer only. After 200 kilometer, right? The 5 liter is getting consumed, which means the output is less than the input. Yes or no? The output is less than input, right? Yes. This is what it should have, but this is what it is traveling. So I can say efficiency of bike is equal to what? It will be 200, which is output, by input, which it should be 250. So tell me, it will be what? 4 by 5, which is 80%. Bike is 80% efficient. Yes or no? Got it? Yes or no? Right? Everyone got this? Yes. So 20% is wasted in heat energy, right? Your bike get heated also, na, right? Heat energy, sound energy, some kind of that energies, right? Okay. Yes. So let's see this problem. I hope all of you understood the concept of efficiency. So machine which is 75% efficient means if you give 100 joule, right, then the output, the work will be done of how many joules? Tell me.
75 joules.
Very good. 75 joule only, right? Yes or no? I hope all of you understood. Okay. So a machine which is 75% efficient uses 12 joule, right, in lifting 2 kg mass to a certain distance, right? This mass is then allowed to fall through that distance. What will be the velocity at the end of its fall? Now, easy. Think about it. Conceptually question, right? When you talk about conceptual question, you have to think about the concept. A machine which is 75% efficient uses 12 joule of energy in lifting 2 kgs to a certain distance. So this machine is lifting this by certain distance. Let's the distance is x. Mass is given as 2 kg. But efficiency is 50% only. And this is using 12 joule. So what is 75% of 12? Tell me. 75% of 12 joule. Tell me. Tell me everyone, what is 75% of 12?
9.
9 joule. Means if it is using 75% of this, right? So out of 12 joule, only 9 joule is converted into potential energy. Only 9 joule is used. Yes or no? Tell me yes or no. Agree with this? Tell me. Agree with this? Right? Means useful work is only 9 joule. Now, this work is done to raise the height, right? Got it? Yes or no? Right? Okay, so I can say when an object is kept from here to here, the energy of this is 9 joule. The energy of this is 9 joule. Agree? Tell me, agree? And when it is dropped, and when it reaches over here, right, I can say, right, this kinetic energy at this point A is equal to potential energy of point B. Yes or no? Yes or no? Yes, Shakib. Used work and unused work. Okay, right? Useful work or waste work. Okay. So kinetic energy is half mv square, and this potential energy should be equal to 9 joule only. 9 joule. So can you calculate v square? What is initial energy, Prahlad? What is initial energy? Tell me, what is initial energy? If work is done 9 joule, then the energy which is stored should be 9 joule only. Yes or no? So at point B, the potential energy is 9 joule. Wait, Yashas, let me explain this now. Right? Yes or no? At point B, what is the energy? 9 joule only. Right, Prahlad? Right? Because the velocity is 0. But when it falls and reaches point A, right, at this point, since it is ground, the potential energy will become 0. It will be kinetic energy only. So this potential energy is converted into this kinetic energy. So this 9 joule is converted into kinetic energy, which is half mv square. So we can calculate V. M is 2. So V is equal to 3 meter per second. Right? Got it, Prahlad? Now, Yashash, tell me what is your doubt?
So it is written that 12 joules of energy is actually used in lifting up a 2 kilo mass. So that means ki the output is a lot more. So the input is a lot more than 12 joules, and 12 joules of energy is the output which is being used to lift a 2 kilogram mass. So
No,
the
it is not
75% can be
It is
12
not that.
joules, right?
It is not that. This 12 joule is used. It used for lifting. It is used by what? Tell me. It is used by what?
The machine, sir.
Used by machine. So it is output or input.
So it can be both if we take the meaning
How
as
it can be
different.
both, right? How
So
it can be both. If it is
sir, if uh, so, for example, let
again,
the
Yashash,
input.
listen to me. Yashash, listen to me. Right? I'm saying if you eat five chapatis, right? Okay. So this is your input, right?
Yes, sir.
Now think about it. If a machine, suppose if your heater is using 500 joule. I'm just using the statement. Heater is using 500 joule, right? What does that mean?
So we're giving it 500 joules of energy. It is using 500 joules is the input.
Using 500 joule to heat water, and efficiency is 80% of heater. Then how much energy is used in heating?
So 400 joules.
How this is different from this? Got it?
Yes, sir.
Okay. Whenever if a machine is using, right, then it is input. Okay, right? And if machine is supplying any energy, right, then it is your output or usable work. Got it, Yashash?
Yes, sir.
Right? Okay. Okay. Everyone got this? See, it is the language. You have to think about the language, right? Sometimes, see why I was like stern on that, because the question is right. You cannot argue that question is wrong, okay? Because it will happen a lot in 11, 12. The question is right. You have to understand from the question's point of view. Okay, got it, right? Because there are
Yes,
many
sir.
times where you seems like question is wrong, but no, question is not wrong. Question is right. Okay, you have to think like that. Okay, okay.
Okay.
Third one, think about third one. Two inclined tracks, one gradual and one other steep. Now this is just logical. This is just logical. Now think about it. If it is at point this and if it is at point this and this, what do you think? They will have same velocity or different velocity? Tell me. Think about it. You don't have to solve, just have to think. V1 will be equal to V2, V1 greater than V2, V1 less than V2. Think about it. If they have same mass M1 is equal to M2. Let's see how many of you understood the concept. Okay, Satvik, very good. Option A, option B, option C. And tell me the reason also. Tell me, Yashash, Yashika, so Yashila. Everyone, tell me the reason. Think about it. Think about it. It is
So
basically
the track AC will have a lot more. So the both will be the same, sir.
same because height, again, potential energy only depends on height. So it doesn't matter if it is point B or C, answer is this. Doesn't matter if it is point B or C, what do you think? What is the height? What's the change in potential energy? Delta U is same or different? Tell me. Right, when it is falling from point A to B or point A to C, change in potential energy is same or different? Same only, na?
Okay.
Because height is same, right? That's what I said. It is path independent. And if potential energy is same, then kinetic energy should also be same. If mass is same, identical stone, right? So mass is same. So kinetic energy is also same. So velocity is also same. Got it, everyone? Tell me, got this concept?
Yes,
Yes,
sir.
easy. Okay. So this is very important concept. You have to think about it. One to seven, guys. Any doubt? Okay, let's see. Question number three. Let's discuss question number three. A car of mass 1000 kg, mass is given, reaches a speed of this, right? 54 kilometer per hour in 5 minutes. So convert it into meter per second. So it will be how much? Tell me. First of all, you have to convert this into meter per second. Why? SI unit, right? So it will be what? 5 by 18? So it will be 15 meter per second, right? In 5 minutes means the time is how much? 300 seconds. What will be the power consumed by vehicle in a given time? Now we know that power is equal to what? Energy by time, yes or no? Basic formula getting. Power is equal to energy by time, yes or no? Agree, yes or no? Right? And this energy is what? Kinetic energy, half mv square by time. Clear? Everyone is clear on this? Right? Yes or no? So formula getting, I hope all of you. So the concept, right, is basic the formula of power, okay, right? And you have to convert this speed in meter per second and time in seconds. Now, eighth you can solve, sorry, fourth you can solve easily. Fourth you can solve easily. Everything is given. We have solved fourth, yes or no? Now, fifth we have done in class. Sixth we have done, right? Power into time is equal to energy, right? Now, seventh one. Let's see seventh one. 3 electric bulb, each power 20 watt, runs for 10 hours per day. So what is the energy? Energy is equal to 20 into 10 watt hour, right? Which is equal to 200 watt hour. This is one bulb, right? For three bulbs, it will be 600 watt hour. Yes or no? Yes or no? Now, electricity bill of 1 unit is 5 rupees. 1 unit is 5 rupees. So this is how many unit? Tell me, this is how many unit? Tell me. No, 1 kilowatt hour. 1 kilowatt hour is equal to 1 unit, right? So this is 0.6 unit. Right? Yes or no? Because it is watt hour, right? It is not kilowatt hour. So it is 0.6 unit. Now, for April, how many days in April? 30. So for 30 days, it will be what? 0.6 into 30. And cost of 1 unit is 5. So into 5. So if you can calculate this, you'll get 90 rupees. Got it, everyone? Tell me, got it? Yes? Clear? Everyone is clear with this? Raise your hand. Yes? The electricity bill is not this cheap now. It is around 7 to 10 rupees. Okay, it is not 5 rupees anymore. Okay, any doubt in homework? 1 to 5? 1 to 5, any doubt in 1 to 5? Every question is easy only. 1 to 5, every question is easy only. Yes, Prahlad, by checking the meter you can calculate. Now, by checking the meter you can calculate. Okay, anyone have any doubt in 1 to 5? No, easy, right? Now, let's see advanced problem of this topic. Advanced problem of this topic. Okay, very good. I'll take attendance after the class, right? So those who are leaving, they'll be absent. So if a force F is applied on a body, and if it moves with velocity, the power will be, I hope all of you remember, power is equal to what? Force into velocity. I hope all of you remember this formula, yes or no? We have derived this in class. Yes, very good. We have derived. Yes, very good, Yashila. Correct, very good. Now, second one, try to solve second one. Try to solve second one. Second one, everyone. Tell me what's the answer? Easy. A man A of mass M 180 kg runs up the stair in 20 seconds, 12 seconds, sorry. So it is T1. Another man of 60 kg runs up the staircase in 11 seconds. So we know that, okay, energy will GH, right, and M2GH, yes or no? Because height is same, na? They are running the same staircase. So height is same, right? So we know that power is equal to E by T, which is equal to P1 is equal to E1, which is M1 GH by T1, and P2 is equal to M2 GH by T2, right? Easy? Tell me, easy? Right? Okay, very good, Yashira. So it will be P1 by P2. P1 by P2 is equal to how much? It will be M1 by M2 into T2 by T1. Yes or no? Take the ratio. 80 by 60 into 11 by 12. Clear? Got it? Right? Got it? So what would be the answer? Everyone tell me. What would be the answer?
11:9.
Yes. Okay.
B.
11:9. So answer is B. Correct? Easy? Okay. So we are done with this. I hope all of you understood this. Okay. Now let's discuss. Very good. This advanced problems. Okay. I'll discuss the concept of advanced problems. You guys can solve at home. Okay. Now, right? Because, or have you solved this advanced problems? Tell me, how many of you solved this? Tell me, how many of you solved this? Raise your hand. No? Yes? So, okay, I'll just give you a hint. Okay, I'll just explain, right? Okay, so that you can solve once again. Now, question number one. Think about question one. I'll just explain the question to you guys. Which of the following statement is correct when we carry a bag and start from point A and stop at point B on the horizontal surface? Now, this is easy, right? Question one is easy. If you're carrying a bag and you're moving, right? So mg is in this direction due to bag and you're moving in this direction. Tell me, what is the correct answer? This is easy one. Tell me everyone, what is the answer? What is the answer? If you walk such that velocity is constant, then since there is no acceleration on
So
the bag.
option B. Option B.
Very good, right? Because the force is vertically upward, the displacement horizontal, work done is zero, right? So the answer is B. Easy? Got it, everyone? Easy? This is what we have discussed a lot. Yes. Question number two. When you continuously push your baby sister who is sitting on a merry-go-round after you complete one circle, tell me, work done is?
A, sir.
Very good. This is something we have already studied, that if you move in circle, the work done will be zero because displacement is zero, right? Yes. So the answer is A. Now, third one. Three boys B and C start from the base of hill a walk. Now, easy. Tell me, easy. Tell me, everyone.
A and B.
What?
C, A and B.
Okay. Anyone else?
Sir, all will be same.
Yes, exactly. Think about it, right? The work done is equal to change in potential energy. Yes or no? This is what we have done, right? Yes or no? We have done the same kind of problems in class exercise. Yes. Yes. Since they are having same height, okay, got it, right? Clear? Okay, clear? Russian, my voice is cracking. See, since they are having same height, okay, and we are ignoring the, tell me, we are ignoring friction. We are ignoring friction over here. It is not mentioned, so we are ignoring friction, right? Got it?
So mg
It
is
is due to,
constant.
yes, mg is constant, right? Height is same. Okay. Now, if friction is considered, then your answer would be correct. Then C, then A, then B. Okay, because friction is not considered, right? Your work done is equal to change in potential energy. Negative of change in potential energy, it will be same because same height is considered. Now, fourth one. Tell me, fourth one.
Sir, this can happen when we consider the ground or the axial, like position where mud is present as our origin, sir.
Which one? Third or fourth?
Fourth, sir.
Okay. Body is on rest on the surface of Earth. If its kinetic and potential energy will be zero, correct. We take it slowly to a height, okay. Its potential energy will increase and become positive, correct. If we dig the tunnel and slowly move the body to the depth and keep it there, will potential energy decrease and become negative in this case? Right?
No, sir. No. It won't be negative, sir. It's scalar. I forgot. I considered it to be a
Think about
vector
it.
and then computed it. Yes, sir. Same.
See,
No, not. It will not be
again,
negative.
wait, everyone, wait. As I told you, it is depending on reference frame, yes or no. And it's not potential energy which is getting negative or negative positive, it is change. Think about it. If you consider potential energy here at zero, think about it. If it is going up, then according to this, the potential energy will increase. So it will be positive, yes or no? Tell me, yes or no?
So in this case, should we take the ground as
According to this point, think about it. According to this point. But if you talk about, if you go down, according to this point, it will be negative. Yes or no? Tell me, think about it. Think about it. Yes or no? But if you choose the reference frame at this point, the reference frame at the depth only, then this is also positive and this is more positive. So what is the correct answer? Tell me, what is the correct answer? The correct answer is, right, it depends on reference frame, right? And here the reference frame is taken as ground, right? Surface of the earth. Yes or no, right? So if it goes up, it will be positive. If it goes down, it will be negative because we talk about change in potential energy. Got it, everyone? Tell me, got this? Everyone got this?
Sir, but after all the cases, sir, the potential energy is a scalar quantity, no, sir. How can it be negative or positive? Like that would make an effect, no, sir.
Wait. Let's think about it. First of all, it is change in potential energy. Now, negative and positive always, right? So it does not always represent direction, right? Okay, here negative means it is decreasing. It is not the direction. Negative means it is decreasing. Got it? Right? Work done is also positive and negative. Now we have discussed, right? If we are doing work done, so when you talk about scalar quantity, positive negative means decrease or increase. Decrease or increase, yes or no? Right? Unlike vectors, which means direction, negative positive means opposite direction. Here, positive negative means increase or decrease. Okay, got it, everyone? Got this concept? My voice is cracking, everyone. My voice is cracking. Is it fine? Prahlad, in retardation, acceleration, again, it is vector quantity, so you can say, okay, but in scalar quantities, negative means it is decreasing, right? According to reference point. Okay, now, Tapish, tell me. Okay, okay, Bhavani. Tapish, you're present. Speak, say, present. My voice is lagging.
Yes, sir.
Question number 6. Tell me, what is the answer of question number 6? Foundation batch, I'll take attendance, right? After discussing 6 and 7. Tell me, question number 6. What's the answer? A bullet of mass 5 kg, sorry, 5 grams, 5 grams, travel speed this, penetrates a fixed target whose resistive force is this. Okay. Janvi, yeah, you're present, don't worry. You're present. Those who are responding, I know that they are present, I mark them present, okay? So tell me, this is a very good problem. Question number 6 is a very good problem. Now, think about it. Think about it. So what is kinetic energy? Tell me, what is the initial kinetic energy? Initial kinetic energy, tell me. Initial kinetic energy is half into 5 into v square. Yes or no? Now, if it penetrates a fixed target whose resistive force is 100 Newton, right? Or you just say v is equal to 500. Resistive force is 1000 Newton. So retardation will be what? 1000 by, tell me, 1000 by 0.005. Yes or no? Shrusti, I'll take attendance of foundation batch now.
So
I've
can
taken
you tell how you wrote A is equal to 1000 by 0.005?
force is equal to mass by acceleration, na? Force is equal to mass by
Okay, sir.
mass into acceleration is equal to force. So force is equal acceleration is
Sir,
equal to force.
but it should be minus 1000, no?
It is minus. I'm just taking retardation, na? Right? I'm taking retardation. So it will be minus only, right?
Okay, sir.
Because it's resistive only. Okay. Now we know that it will stop. So v is equal to 0. U is this. So we can use v square is equal to u square minus 2as. S you can calculate. Yes or no? Tell me. Yes or no? Right? Clear? Okay. Second one. Tell me. Second one you can solve. Yes. So the kinetic energy with which the bullet will emerge the target if its thickness is 50 centimeter. So from here you will calculate something which will be more than 50. Now, if the thickness is 50 centimeter, then you have to calculate distance is given, right? S is given, A you know, U you know. You have to calculate V. So same formula, V square is equal to U square, right? Minus 2AS. Now in this case, S is equal 50 centimeter given, you have to calculate V. Got it? Everyone got it? Okay. Okay, seventh one is easy. Okay. Now, tell your attendance, everyone. Tell your attendance, foundation batch. Board students, you can leave now. Okay, thank you, everyone. Thank you.